Chapter 7. Probability and Lottery. This section of the book is about calculating lottery odds or probabilities. In a typical lottery game, each player chooses 6 different numbers from 1 to 49. If the 6 numbers which player choose match numbers which are drawn during a game by the lottery, the player wins a jackpot prize, regardless of the arrangement of the chosen numbers. The probability of this to occur is 1 in 13,983,816. This is the formula for permutations where order is important. P, begin parentheses, n, k, end parentheses, equals n exclamation point divided by begin parentheses, n minus k, end parentheses, exclamation point. This is the formula for combinations where order isn't important. C, begin parentheses, n, k, end parentheses, equals n divided by k, equals n exclamation point divided by k exclamation point, begin parentheses, n minus k, end parentheses, exclamation point. This can be demonstrated easily. The first number drawn has a 1 to 49 chance to be a matching number. The second number has a 1 to 48 chance to be a matching since the ball is already drawn and isn't returning to the machine. Therefore, the probability of matching 2 numbers drawn from 49 in the correct arrangement is calculated as 1 to 49 multiplied by 48. Following the third number, there are only 47 ways of matching that number, and the probability is 1 to 49 multiplied by 48 multiplied by 47. This calculation follows other 4 numbers that have been drawn from the lottery machine. The final count is the total number of balls, which is 49, divided by that same number minus 6 balls which are drawn. The result is 10,068,347,520, which is the probability of winning a grand prize from a single lottery ticket. However, in lottery games, the order of the 6 numbers doesn't matter. So if the ticket contains the numbers 6, 5, 4, 3, 2, 1 in any order, it wins. According to this, when we multiply these numbers, there is 720 possible orders in which those numbers could be drawn. The alternative way to calculate lottery odds is to note that the probability of the first ball drawn to be corresponding to one of 6, which are chosen, is 6 out of 49. Following the probability of the second ball to be corresponding to one of the remaining numbers is 5 out of 48. And so on. This yields a formula where we divide the total number of alternatives, which is 49, with the total number of choices, which is 6. This function is called combination formula, which we discussed previously in this book. The final result is the same as when using the previous method. The range of combinations for a lottery is referred to as number space. On the other hand, coverage is the percentage of that number space that is in a game for a given drawing. Following is probability formula to calculate likelihood of having 6 matching numbers in Grand Lotto, which features 55 balls. Another type of lottery game is Pick 832 by Trillion Coins. This lottery game implements a game ticket where 8 numbers from 1 to 32 are selected, not depending on any order, and the repetition of numbers is allowed. The odds of matching all of the 8 numbers drawn can be calculated following the previous pattern when the probability of the first ball to be matching is 8 out of 32. The probability for a second to be matching is 7 out of 32, and so on. Therefore, the probability of matching all 8 numbers is 1 in 27,269,633.